BREEAM. Part 1. What is BREEAM? Introduction to BREEAM. BREEAM, Building Research Establishment Environmental Assessment Method, is a leading and internationally recognized sustainability assessment method for evaluating the environmental performance of buildings. Developed in the United Kingdom in 1990 by the Building Research Establishment, BREEAM provides a comprehensive framework for assessing, rating, and certifying the sustainability of buildings across various categories. These categories include energy usage, water efficiency, material selection, waste management, indoor environmental quality, and innovation in design. The BREEAM assessment was designed to help reduce the negative environmental impact of buildings by promoting sustainable practices and encouraging the construction of environmentally responsible buildings. It offers a clear and measurable way to assess a building's environmental impact and sustainability performance throughout its life cycle, from design to construction and operation. Since its inception, BREEAM has grown from a UK-based certification system into an internationally recognized standard. Today, BREEAM assessments are applied to buildings and developments around the world, making it one of the most popular environmental rating systems globally. History and evolution of BREEAM. BREEAM was the brainchild of the Building Research Establishment, BREE, a UK-based research organization that has been at the forefront of developing sustainable building technologies and practices. The system was introduced in response to growing concerns about environmental degradation, resource consumption, and the negative impacts of construction on both the environment and human health. The first version of BREEAM was launched in 1990, focusing on office buildings in the UK. Over time, BREEAM expanded its scope to include a wide variety of building types, such as retail, residential, industrial, educational, and healthcare buildings. In the early years, the system was based primarily on energy efficiency, but it soon grew to encompass a broader range of sustainability concerns, including waste management, water usage, and the use of sustainable materials. As the demand for sustainable buildings grew, BREEAM evolved and adapted to keep pace with advancements in building technology, environmental science, and regulatory requirements. Today, BREEAM offers specialized assessment tools for various building types and regions, including international BREEAM schemes for projects outside the UK. Purpose and importance of BREEAM. The central purpose of BREEAM is to encourage the development of buildings that are not only environmentally sustainable, but also economically viable and socially responsible. By certifying buildings that meet specific sustainability standards, BREEAM helps to foster a more sustainable construction industry and promotes responsible building practices that address key environmental challenges such as climate change, resource depletion, and poor indoor air quality. BREEAM provides several benefits to all stakeholders involved in the building life cycle, including developers and builders. BREEAM helps developers differentiate their projects in a competitive market, particularly as sustainability becomes a key consideration for investors and tenants. It offers a clear framework for improving environmental performance and reducing operational costs over time, resulting in long-term value for developers and property owners. Occupants and tenants. Buildings that achieve BREEAM certification tend to have better indoor environmental quality, providing occupants with healthier, more comfortable living and working spaces. Studies have shown that BREEAM-certified buildings often experience higher occupancy rates, greater tenant satisfaction, and improved worker productivity. Communities and the environment. BREEAM-certified buildings are typically designed to minimize environmental impact, reduce resource consumption, and promote energy efficiency. As a result, they contribute to the reduction of greenhouse gas emissions, the conservation of natural resources, and the overall improvement of community well-being. Governments and policymakers. BREEAM serves as a valuable tool for policymakers who aim to create a regulatory framework that supports sustainable development. By encouraging the use of BREEAM, governments can help reduce the environmental footprint of the construction industry, align with global sustainability goals, and meet obligations related to climate change and building performance. Key features of BREEAM certification. BREEAM offers a comprehensive and adaptable rating system that is used to assess the environmental performance of buildings. Key features of the BREEAM certification process include comprehensive criteria. BREEAM covers multiple sustainability aspects, including energy efficiency, water management, indoor air quality, material selection, waste management, and innovation. These criteria ensure that all areas of environmental impact are considered during the building design and construction process. Performance-based. BREEAM is a performance-based assessment system, meaning that buildings are evaluated based on their actual environmental performance rather than theoretical designs or construction methods. This approach encourages real-world sustainability outcomes and ensures that buildings perform well throughout their life cycle. Rating levels. BREEAM uses a system of ratings to recognize varying levels of environmental performance. The rating levels range from pass, minimum performance, to outstanding, exceptional performance, providing a clear indication of a building's sustainability credentials. The rating is based on the number of points earned in different categories, with each point reflecting the building's performance in a specific environmental area. Independent verification. BREEAM assessments are carried out by qualified assessors who independently verify the building's compliance with the relevant criteria. This ensures transparency and credibility in the certification process, providing confidence to developers, tenants, and other stakeholders. Conclusion. BREEAM is more than just an environmental certification. It is a driving force for positive change in the construction industry. By setting high standards for sustainability and offering a clear, measurable way to assess building performance, BREEAM helps to ensure that buildings are not only environmentally responsible, but also economically beneficial and healthy for their occupants. With its global reach and wide application, BREEAM has become a critical tool in the effort to create more sustainable, resilient, and energy-efficient buildings worldwide. In the next part, we will explore the different BREEAM standards and ratings in greater detail, providing a deeper understanding of the certification process and the criteria that buildings must meet to achieve each rating level. Part 2. BREEAM Standards and Ratings. Overview of BREEAM certification levels. One of the defining features of BREEAM, Building Research Establishment Environmental Assessment Method, is its clear and structured rating system, which provides a transparent way to assess a building's environmental performance. BREEAM ratings help to communicate how sustainable a building is based on a range of criteria, and they encourage the design and construction of buildings that minimize environmental impact. BREEAM certification is awarded based on the number of points a building earns in various categories of sustainability, with different levels of certification corresponding to different points thresholds. The BREEAM rating system is divided into 5 key certification levels, each of which reflects different stages of sustainability achievement. These levels are: Pass. This is the minimum level of achievement and indicates that the building meets the basic requirements for sustainability. It represents a bare minimum performance standard and is often considered a starting point for more ambitious sustainability efforts. Good. A building that achieves a good rating demonstrates a solid commitment to environmental sustainability. It reflects the efforts made to reduce the building's environmental impact and provides a more comfortable, energy-efficient space compared to typical construction practices. Very good. A very good rating represents a high level of performance and indicates that the building has met a stringent set of environmental criteria. This level is often sought after by developers and occupiers who want to balance sustainability with economic and operational considerations. Excellent. Achieving an excellent rating is a mark of high sustainability performance. Buildings rated excellent go above and beyond to meet environmental standards and demonstrate a strong commitment to reducing their environmental footprint. These buildings typically employ advanced sustainability technologies and practices. Outstanding. The highest possible rating, outstanding, is reserved for buildings that demonstrate exceptional environmental performance. These buildings represent the pinnacle of sustainability in the built environment, with advanced features in energy efficiency, resource management, and overall environmental impact. The outstanding rating indicates that the building has set a new benchmark for sustainability in construction. Each of these levels reflects the number of points a building earns during the assessment process. The total number of points earned is directly tied to the building's overall environmental performance across a wide variety of categories, such as energy use, materials, water, waste, and indoor environmental quality. BREEAM categories and credits. To understand how a building earns points and ultimately achieves one of the 5 rating levels, it's essential to explore the BREEAM categories. The BREEAM assessment evaluates a building's environmental impact across 10 key categories. Each category is further divided into specific criteria or credits, which address different aspects of building performance. The total number of credits available in each category varies, and buildings earn credits based on how well they meet or exceed the specific requirements set out in the BREEAM manual for that category. Below are the key BREEAM categories. Management. The management category covers sustainable building practices in terms of project management, compliance, and operational processes. It includes credits for the management of the design and construction process, the involvement of stakeholders, and the commissioning of the building. Key credits: project team collaboration, sustainability goals, building maintenance and operation plans, and performance monitoring. Health and well-being. This category focuses on creating healthy and comfortable indoor environments for occupants. It includes criteria related to indoor air quality, thermal comfort, lighting, acoustic performance, and access to daylight. The goal is to improve occupant satisfaction, well-being, and productivity. Key credits: indoor air quality, thermal comfort, lighting levels, ventilation, and quality of indoor spaces. Energy. The energy category is one of the most critical areas of the BREEAM assessment. It evaluates a building's energy efficiency, greenhouse gas emissions, and the use of renewable energy sources. The aim is to reduce operational energy consumption and carbon emissions, contributing to a building's environmental sustainability. Key credits: energy performance, renewable energy use, low-carbon technologies, and overall building energy efficiency. Transport. The transport category addresses the impact of transportation related to the building, including access to public transport, parking facilities for low-emission vehicles, and provisions for cycling and walking. The goal is to minimize the carbon footprint associated with travel and reduce dependence on private cars. Key credits: accessibility to public transport, provisions for cycling, electric vehicle charging points, and carpooling. Water management is a critical part of sustainability, and this category focuses on minimizing water consumption, promoting water conservation, and improving the management of water resources. Buildings are assessed for water-efficient technologies and systems that reduce the demand for water, while ensuring the well-being of occupants. Key credits: water-efficient fixtures, rainwater harvesting, water metering, and water management systems. Materials. The materials category assesses the selection and use of building materials, encouraging the use of sustainable and responsibly sourced materials. This category aims to reduce the environmental impact of material production and consumption, focusing on resource efficiency and waste reduction. Key credits: use of sustainable materials, recycling of materials, minimizing waste, and sourcing materials with a low environmental impact. Waste, WST. The waste category focuses on reducing waste generation during construction and throughout the building's life cycle. This includes strategies for reducing, reusing, and recycling materials, as well as the management of construction and demolition waste. Key credits: waste management plans, recycling facilities, and diversion of waste from landfills. Land use and ecology, LA. This category examines the ecological impact of the building on its site and surrounding environment. It encourages developments that enhance biodiversity, promote the responsible use of land, and minimize adverse impacts on ecosystems. Key credits: site ecology, habitat enhancement, pollution reduction, and protecting natural habitats. Pollution, POL. The pollution category focuses on minimizing the building's environmental pollution during both construction and operation. This includes the reduction of emissions to air, water, and soil, as well as strategies to prevent light pollution and noise disturbance. Key credits: reducing greenhouse gas emissions, controlling pollutants, and minimizing light and noise pollution. Innovation. The innovation category rewards projects for going beyond the standard BREEAM requirements and introducing innovative measures that improve the building's sustainability. This may involve the use of cutting-edge technologies, design strategies, or creative solutions to sustainability challenges. Key credits: innovative design features, new technologies, and cutting-edge sustainability practices. How BREEAM points are calculated. Each of these categories is assigned a number of points, depending on the importance of the sustainability issue it addresses. The building score in each category is based on how well it meets the specific requirements outlined in the BREEAM manual. After the building is evaluated in each category, the points are totaled and used to determine the final BREEAM rating. The scoring system for BREEAM is designed to reward the building for incorporating a range of sustainable features and technologies. A higher number of points corresponds to better performance across multiple sustainability categories, which leads to a higher overall rating. Conclusion: BREEAM's system of ratings and categories provides a clear, transparent method for assessing the environmental performance of buildings. From pass to outstanding, each certification level reflects a building's level of sustainability achievement. By addressing a wide array of environmental concerns, from energy efficiency and water management to material selection and occupant health, BREEAM helps guide developers, architects, and building owners toward creating buildings that are environmentally responsible, resource efficient, and healthier for occupants. In the next part, we will explore the BREEAM assessment process in more detail, outlining the steps involved in obtaining BREEAM certification and the roles of various stakeholders. Part 3. Global Adoption and Influence. BREEAM's international expansion. While BREEAM originated in the United Kingdom in 1990, it quickly gained recognition beyond the UK borders due to its comprehensive approach to environmental sustainability in building design and construction. As the global demand for sustainable building practices grew in the early 21st century, BREEAM expanded its influence and began to be adopted in numerous countries around the world. The internationalization of BREEAM was facilitated by its flexibility. The assessment system could be adapted to various environmental, cultural, and regulatory contexts, making it suitable for use in different countries and building types. BREEAM has since become one of the most widely recognized and adopted sustainability certifications globally, providing a benchmark for assessing the environmental performance of buildings in over 80 countries. Regional and international BREEAM schemes. In its global journey, BREEAM has developed tailored schemes to address the specific challenges and regulatory environments of different regions. These regional schemes ensure that the assessment criteria are relevant to the local context, while still maintaining the core principles of sustainability that make BREEAM so effective. Some of the key international BREEAM schemes include BREEAM UK. As the original BREEAM system, the UK version remains one of the most widely used. It has been the standard for many UK-based projects for decades and has influenced other countries' sustainability assessments. The UK version is continuously updated to incorporate the latest environmental challenges, technological advancements, and regulatory changes. BREEAM International. BREEAM International is designed for projects outside the UK and allows for the certification of buildings globally. This version of BREEAM is customized for specific regions, with regional addenda and criteria that align with local conditions and sustainability priorities. BREEAM International projects can be assessed in a similar manner to those in the UK, but adapted to regional needs. BREEAM Europe. For European Union countries, BREEAM Europe provides a regional framework to assess buildings across the continent. It includes region-specific criteria, while maintaining alignment with the overarching BREEAM principles. The goal of BREEAM Europe is to help EU countries meet their collective sustainability targets, such as reducing carbon emissions and promoting energy efficiency. BREEAM Middle East and North Africa, MENA. The Middle East and North Africa have unique environmental and economic conditions, such as extreme weather conditions, limited water resources, and rapid urbanization. BREEAM MENA adapts the assessment criteria to address these challenges while promoting sustainable building practices that help reduce energy consumption, water usage, and carbon emissions in this region. BREEAM USA. In the United States, BREEAM USA has gained traction as an alternative or complement to leadership in energy and environmental design, which has traditionally been the dominant green building certification system. The BREEAM USA scheme emphasizes energy performance, environmental quality, and resource efficiency, while also considering local climate and regulatory conditions. BREEAM Asia Pacific. BREEAM is also expanding rapidly in the Asia-Pacific region, where countries such as China, Japan, India, and Australia are seeing a rising demand for green buildings. BREEAM's ability to adapt to local market conditions, sustainability goals, and regulatory standards has made it an attractive option in these rapidly growing economies. Global case studies of BREEAM's influence. The influence of BREEAM can be seen in numerous landmark projects worldwide. By promoting best practices in sustainable construction, BREEAM has contributed to the development of high-performance buildings that serve as models of energy efficiency, resource conservation, and occupant well-being. Here are a few prominent examples of BREEAM certified projects that highlight its global reach. The Crystal, London, UK, one of the world's most sustainable buildings. The Crystal in London was awarded a BREEAM Outstanding rating, the highest possible level. This building, which houses an exhibition on sustainable cities, was designed with cutting-edge technologies to reduce energy consumption, including a combined heat and power (CHP) system, solar panels, and extensive water-saving measures. Its green roof, energy-efficient lighting, and sustainable materials contribute to its status as a landmark project for both sustainability and innovation. The Edge, Amsterdam, Netherlands. The Edge, located in Amsterdam, is a prime example of how BREEAM can be used to achieve an exceptionally high level of environmental performance. This office building achieved a BREEAM Outstanding rating with an innovative approach to energy use, which includes smart building technologies and advanced lighting systems. The building's design reduces energy use by integrating a smart building management system that automatically adjusts temperature, lighting, and even workstation location based on occupancy. Marina Bay Sands, Singapore. Marina Bay Sands, an iconic resort in Singapore, achieved a BREEAM Excellent rating for its environmental design and sustainability initiatives. The building integrates energy-efficient features such as water-saving fixtures, solar panels, and a comprehensive waste management system. The Marina Bay Sands project exemplifies how BREEAM can be successfully applied to large, high-profile developments in the Asia-Pacific region. The Bulgari Hotel, Milan, Italy. This luxury hotel in Milan is another example of how BREEAM has influenced the hospitality industry. The Bulgari Hotel achieved a BREEAM Excellent rating by incorporating sustainable materials, energy-efficient systems, and advanced waste management practices into its design. The hotel also focuses on the health and well-being of its guests by ensuring high-quality indoor air and lighting. BREEAM's impact on global sustainability goals. BREEAM has not only been a powerful tool for transforming individual buildings, but has also contributed to achieving larger global sustainability goals, including those set by international organizations and treaties. For example, United Nations Sustainable Development Goals, SDGs. BREEAM directly contributes to several of the SDGs, particularly 11 Sudanese pounds, Sustainable Cities and Communities, 12 Sudanese pounds, Responsible Consumption and Production, and 13 Sudanese pounds, Climate Action. By promoting energy-efficient designs, waste reduction, water conservation, and the use of sustainable materials, BREEAM supports efforts to reduce the environmental impact of the built environment and mitigate climate change. Paris Agreement on Climate Change. The construction and operation of buildings account for a significant portion of global carbon emissions. By encouraging buildings to meet high sustainability standards, BREEAM helps nations meet their carbon reduction targets under the Paris Agreement. BREEAM's focus on reducing energy consumption, carbon emissions, and resource use plays a critical role in achieving global climate goals. Local government and policy alignment. Many local governments have adopted BREEAM as part of their sustainability strategies. BREEAM certified buildings align with local sustainability codes and help cities meet their environmental regulations and carbon reduction targets. For instance, in several European cities, achieving BREEAM certification is a requirement for obtaining planning permissions for new developments. Challenges and opportunities in global adoption. While BREEAM has achieved considerable global success, its widespread adoption has not been without challenges. Different countries and regions have varying environmental priorities, regulatory frameworks, and construction practices, which can sometimes make it difficult to implement a one-size-fits-all sustainability standard. However, BREEAM's flexibility and adaptability have allowed it to overcome these challenges and provide a consistent and effective system for assessing building sustainability across diverse contexts. Opportunities for future growth. The future of BREEAM looks promising as global demand for sustainable buildings continues to rise. As awareness of environmental issues such as climate change, resource depletion, and pollution increases, the need for green building certification systems like BREEAM will only grow. In particular, the increasing focus on the life cycle of buildings, from construction to operation and demolition, creates significant opportunities for BREEAM to shape the future of the built environment. Furthermore, as new technologies emerge, BREEAM will continue to evolve to incorporate innovations such as smart buildings, renewable energy integration, and advanced waste management systems. These advancements will help ensure that BREEAM remains a leader in sustainable building practices for years to come. Conclusion. BREEAM's global reach and influence have made it a cornerstone of the sustainability movement in the built environment. By providing a reliable and adaptable framework for assessing the environmental performance of buildings, BREEAM has helped developers, designers, and governments around the world meet their sustainability goals and reduce their environmental impact. As the world continues to grapple with the challenges of climate change and resource depletion, BREEAM will remain a vital tool in the creation of a more sustainable future. Part 4. The BREEAM Assessment Process. Overview of the BREEAM Certification Process. Obtaining BREEAM certification involves a structured and systematic assessment process that evaluates a building's environmental performance. The process begins early in the design phase and continues through construction and post-construction stages. The goal is to ensure that sustainability is integrated into every step of the building's life cycle. The BREEAM assessment process is divided into several stages, from pre-assessment to certification, and involves a range of stakeholders, including the project team, the BREEAM assessor, and the building owner. Each of these stages is designed to ensure that the building meets the necessary sustainability criteria and performs to the highest environmental standards. 1. Pre-assessment. Before formally submitting a project for BREEAM certification, a pre-assessment is conducted to provide a rough idea of how likely the project is to achieve a particular rating. This stage is highly beneficial for the project team to understand which sustainability features are achievable and to identify areas where improvement may be needed. Purpose of pre-assessment. A pre-assessment is often used to gauge the likely outcome of the BREEAM certification for the project, allowing for early decision-making on design and construction practices. It helps to set expectations for the project team, ensuring that the building's environmental goals are clearly defined. Process. During pre-assessment, the project team, including the architect, engineers, and sustainability consultant, works together to determine which BREEAM credits can be achieved based on the proposed design. This can be done using the BREEAM assessment tools or through discussions with a BREEAM assessor. Outcome. The pre-assessment will result in a preliminary score for the building based on the credits that are anticipated to be earned. This score gives the project team a good indication of the final rating and highlights any gaps in sustainability performance that may need addressing. 2. Appointment of a BREEAM assessor. A qualified BREEAM assessor plays a critical role throughout the assessment process. They are responsible for guiding the project through the BREEAM certification journey, ensuring compliance with the BREEAM criteria, and ultimately verifying that the building meets the necessary sustainability standards. BREEAM assessors are trained professionals with expertise in building performance, sustainability practices, and the technical details of the BREEAM system. Role of the BREEAM assessor. The BREEAM assessor conducts the detailed assessment of the building's performance based on the pre-agreed criteria. They may suggest design improvements, provide advice on achieving additional credits, and ensure that the project complies with the necessary standards. The assessor is responsible for submitting the documentation to BREEAM for review and certification. Choosing the right assessor. It is important to select a BREEAM assessor who is experienced in the relevant BREEAM scheme, e.g., BREEAM UK, BREEAM International, and who understands the specifics of the building type. The right assessor can significantly influence the success of the certification process by offering insightful recommendations and minimizing any delays. 3. Design stage assessment. The next key stage of the BREEAM certification process is the design stage assessment. During this stage, the project team works to implement the building's design based on the sustainability criteria laid out by BREEAM. This is where most of the credits are earned and is crucial in determining the eventual rating. Key focus areas. At this stage, the design team focuses on incorporating sustainable features such as energy-efficient systems, water-saving technologies, waste management strategies, and material selections that meet BREEAM sustainability requirements. The design must meet the specific criteria within each of the BREEAM categories to earn points. BREEAM credit evidence. Each credit that is sought during the design stage requires documented evidence that the building meets the required standards. This may include technical specifications, energy models, design drawings, and other forms of verification. The BREEAM assessor will review this documentation to ensure it meets the requirements. Design stage report. After reviewing the design and supporting evidence, the assessor compiles a report that outlines the building's performance in relation to the BREEAM credits. The report will show how many credits the building is expected to achieve and provide a preliminary score. If any credits have been missed or areas need improvement, the assessor will make recommendations for adjustments before moving on to the next stage. 4. Construction stage assessment. Once the design has been finalized and construction begins, the construction stage assessment comes into play. This stage verifies that the building is being constructed according to the design specifications and that the sustainability measures identified in the design stage are being properly implemented. Construction monitoring. The construction stage is an ongoing process where the assessor monitors the construction progress to ensure that the building meets the sustainability commitments made during the design phase. Regular site inspections, along with progress reports, help to ensure compliance with BREEAM standards. Quality assurance. Throughout the construction phase, the BREEAM assessor ensures that all materials, systems, and technologies meet the sustainability standards specified in the design documents. This includes checking whether sustainable materials are being used, energy-efficient systems are being installed, and waste management strategies are being followed. Evidencing credits. For each credit, the assessor collects evidence during construction, such as photographs, material certifications, installation reports, and contractor statements. This evidence is essential to ensure that the building actually delivers on its sustainability promises. 5. Post-construction and final assessment. After construction is complete and the building is ready for occupancy, the post-construction stage assessment is carried out. This final assessment verifies that the building has been completed according to the approved design and sustainability standards. It is during this stage that the final certification is awarded. Final verification. The BREEAM assessor conducts a final review of all relevant documentation and evidence gathered throughout the design, construction, and commissioning phases. This may include reviewing performance data, such as energy and water usage reports, as well as assessing whether all sustainability features have been successfully implemented. Performance testing. In some cases, performance tests may be required to verify that the building meets the required environmental standards. This could include testing indoor air quality, checking energy consumption, or conducting water usage assessments to ensure the building performs as expected. Final BREEAM certification. Based on the post-construction assessment, the BREEAM assessor submits the final report to BREEAM, Building Research Establishment. Once all the criteria have been met and the evidence is confirmed, the building is awarded the final BREEAM rating: pass, good, very good, excellent, or outstanding. 6. Certification and occupancy. Once the BREEAM certification has been granted, the building receives its official BREEAM certificate, and the project team can showcase their achievement. The building owner can use the BREEAM certification as a marketing tool to highlight their commitment to sustainability and attract environmentally conscious tenants or buyers. Ongoing monitoring. While the BREEAM certification is a one-time process, it is often beneficial for building owners to continue monitoring building performance and maintaining sustainability practices post-certification. Some BREEAM schemes, such as BREEAM in use, offer ongoing assessments of a building's operational performance to ensure that sustainability standards are continually met. Conclusion. The BREEAM certification process is a detailed and multi-stage procedure that requires careful planning, collaboration, and ongoing commitment to sustainability. From the early stages of pre-assessment and design to the final post-construction review, every aspect of the building's life cycle is considered to ensure that it meets the highest standards of environmental performance. With a BREEAM certified building, owners, developers, and occupants benefit from lower operational costs, improved environmental performance, and a healthier, more sustainable living or working environment. In the next part, we will explore the costs and benefits associated with BREEAM certification, helping to understand the long-term value that BREEAM can bring to projects and stakeholders. Part 5. Costs and benefits of BREEAM certification. Introduction. The value of BREEAM certification. Obtaining BREEAM, Building Research Establishment Environmental Assessment Method, certification represents a significant commitment to sustainability, energy efficiency, and environmental stewardship. While BREEAM certification provides numerous environmental, social, and economic benefits, it also comes with certain costs. Understanding both the costs and the benefits of pursuing BREEAM certification is essential for developers, building owners, and other stakeholders to make informed decisions about whether the certification aligns with their project goals. In this part, we will explore both the direct and indirect costs associated with obtaining BREEAM certification, as well as the wide range of benefits it offers to building projects and their occupants. Costs of BREEAM certification. While the benefits of BREEAM certification are significant, it is essential to recognize the costs involved in obtaining the certification. These costs can vary widely depending on several factors, including the size and complexity of the project, the location, and the specific BREEAM scheme being used. Below are the main categories of costs associated with BREEAM certification. A. Pre-assessment costs. Before beginning the full BREEAM assessment, many projects opt for a pre-assessment, which provides an early indication of how likely the project is to achieve a specific rating. This stage involves an initial review of the design, identifying potential sustainability credits, and setting expectations for the building's environmental performance. Consultant fees. Engaging sustainability consultants to conduct a pre-assessment and prepare for the BREEAM certification process incurs fees. Consultants will analyze the proposed design and provide advice on how to meet BREEAM criteria. Time and resources. The pre-assessment process also requires time from the design team, including architects, engineers, and other stakeholders. This initial stage may add to the project timeline, especially if it involves more detailed sustainability planning. B. BREEAM assessor fees. One of the most significant costs in the BREEAM certification process is the fee paid to a licensed BREEAM assessor. The assessor is responsible for guiding the project through the assessment stages, reviewing design and construction details, and submitting documentation for final certification. Assessor's fees. The cost of a BREEAM assessor typically depends on the size and complexity of the project. Larger or more complex projects may require more time and resources from the assessor, resulting in higher fees. Time and coordination. The BREEAM assessor's time and coordination with the project team throughout the design, construction, and post-construction phases add to the overall cost. The assessor will ensure that all sustainability measures are documented and provide ongoing advice to ensure the project achieves its sustainability goals. C. Implementation costs. Achieving BREEAM certification often requires making design or construction modifications to meet sustainability criteria. These modifications can increase the initial upfront cost of a project, but are often offset by the long-term savings associated with energy and resource efficiency. Design and materials. The use of sustainable materials, such as low-carbon or recycled materials, may come at a premium compared to standard options. Additionally, integrating energy-efficient systems, water-saving technologies, and sustainable infrastructure may require higher initial investment costs. Technology and systems. Incorporating green technologies such as renewable energy sources, solar panels, wind turbines, energy-efficient HVAC systems, or advanced building management systems (BMS) can increase the upfront costs. However, these systems often provide long-term savings by reducing operational energy use. D. Performance testing and certification fees. After construction is complete, the building must undergo final verification through performance testing. This may involve hiring specialized consultants or contractors to conduct tests, such as energy performance audits or indoor air quality assessments. Testing costs. Some BREEAM credits require testing and certification of building systems, such as energy use, water efficiency, and air quality. Testing costs depend on the scope of the testing required and the complexity of the systems involved. BREEAM registration and certification fees. BREEAM, Building Research Establishment, the organization behind BREEAM, charges a fee for registering a project and for issuing the final BREEAM certificate. The cost of registration is typically based on the size of the project and the BREEAM rating being pursued. The certification fee is separate from the assessor's fees and covers the final review and awarding of the certification. Benefits of BREEAM certification. While there are costs associated with obtaining BREEAM certification, the long-term benefits far outweigh these expenses. These benefits can be divided into several categories, including financial, environmental, operational, and social advantages. Below, we explore the most prominent benefits of achieving BREEAM certification. A. Financial benefits. Achieving BREEAM certification provides several financial benefits, including cost savings, increased asset value, and improved profitability. Operational cost savings. One of the most significant financial benefits of BREEAM certified buildings is reduced operational costs. Sustainable buildings are designed to be more energy and water efficient, which lowers utility bills and operating expenses. These savings can be substantial over the life of the building, particularly with energy-efficient systems, renewable energy technologies, and water-saving fixtures. Increased asset value. BREEAM certified buildings tend to have higher market value compared to non-certified buildings. Due to their energy efficiency, sustainability features, and reduced environmental impact, these buildings are more attractive to investors, tenants, and buyers. As demand for green buildings rises, BREEAM certification can help to increase the building's resale or lease value. Reduce lifecycle costs. By investing in sustainable building practices, developers can reduce the long-term lifecycle costs of maintaining and operating a building. Energy-efficient systems, low-maintenance materials, and waste reduction measures often result in lower maintenance and replacement costs. B. Environmental benefits. BREEAM certification helps to minimize the environmental impact of a building, making it a vital tool for addressing climate change and promoting sustainability. Reduced carbon footprint. BREEAM certified buildings are designed to have a lower carbon footprint, both during construction and throughout their operational life. By focusing on energy efficiency, the use of renewable energy, and sustainable materials, BREEAM contributes to reducing greenhouse gas emissions and mitigating climate change. Conservation of resources. Sustainability is a core principle of BREEAM, and certified buildings focus on conserving resources such as water, energy, and raw materials. Water-saving technologies, waste recycling systems, and energy-efficient infrastructure all play a role in minimizing resource consumption. Biodiversity and ecosystem protection. BREEAM encourages projects to preserve natural habitats and protect local biodiversity. This could involve creating green roofs, restoring natural landscapes, or using eco-friendly materials that have minimal environmental impact. C. Operational benefits. BREEAM certification is also beneficial for building operations and occupant experience. Many of the sustainability measures incorporated into a BREEAM certified building lead to enhanced building performance. Enhanced energy efficiency. BREEAM certified buildings are equipped with advanced energy-efficient systems such as LED lighting, high-performance insulation, and low-energy heating and cooling systems. These features ensure that the building operates efficiently, reducing overall energy consumption. Health and well-being. A BREEAM certified building is designed to improve the health and well-being of its occupants by ensuring better indoor air quality, natural lighting, thermal comfort, and noise control. These factors contribute to greater occupant satisfaction and productivity. Resilience to climate change. BREEAM emphasizes building resilience, which ensures that buildings can withstand the impacts of climate change, such as extreme weather events. Features such as water-efficient landscaping, flood-resistant designs, and the use of natural ventilation help buildings adapt to changing environmental conditions. D. Social benefits. BREEAM certification can also offer broader social benefits, particularly in terms of community engagement, social responsibility, and improved quality of life for building occupants. Community engagement. Sustainable buildings often contribute positively to local communities by creating healthy environments for residents and workers. For example, green buildings may include features that promote social interaction, such as shared outdoor spaces, walking paths, or community gardens. Corporate reputation. For businesses and developers, achieving BREEAM certification enhances corporate reputation and demonstrates a commitment to sustainability. This can increase a company's attractiveness to clients, investors, and customers who prioritize environmental responsibility. Employee satisfaction and productivity. For commercial buildings, BREEAM certification can lead to higher tenant satisfaction and employee productivity. Factors such as improved air quality, better lighting, and thermal comfort create a healthier and more comfortable working environment. Long-term value and ROI. In the long run, the return on investment (ROI) from BREEAM certification is often substantial. Although the upfront costs can be higher, the ongoing savings, increased marketability, and long-term operational efficiencies make BREEAM certified buildings a wise investment. Building owners and developers can see a return through reduced operational costs, higher rents or sale prices, and a more resilient, future-proof building that meets the increasing demand for sustainability in the built environment. Conclusion. The decision to pursue BREEAM certification involves a careful balance of costs and benefits. While there are some initial investments in terms of consultant fees, assessor costs, and design modifications, the long-term financial, environmental, operational, and social benefits of certification far outweigh these expenses. BREEAM certification not only results in reduced energy costs, improved environmental performance, and a higher quality building, but also enhances the reputation of building owners and developers in an increasingly sustainability-conscious market. The value of BREEAM is not just in the certification itself, but in the positive impact it has on the building's life cycle and the world. Part 6. The impact of BREEAM on building performance and occupant experience. Introduction. Enhancing performance through sustainability. BREEAM, Building Research Establishment Environmental Assessment Method, certification goes beyond a simple environmental rating. It signifies a commitment to integrating sustainability into every aspect of building design, construction, and operation. One of the key benefits of BREEAM certified buildings is the improvement in overall building performance. These buildings tend to be more energy efficient, resilient, and environmentally friendly, offering long-term value to owners and occupants alike. However, the impact of BREEAM is not limited to the physical performance of the building. BREEAM also plays a crucial role in enhancing the occupant experience by promoting health, well-being, and productivity within the built environment. This part explores how BREEAM positively impacts both the performance of the building itself and the people who use it. Building performance, efficiency, and resilience. BREEAM certification encourages the implementation of best practices in energy and resource management, which directly enhances building performance. From energy efficiency to sustainable materials, the improvements made to meet BREEAM standards contribute to a building's overall resilience and long-term operational success. Energy efficiency and cost savings. One of the primary goals of BREEAM is to reduce a building's carbon footprint and operational costs by improving energy efficiency. BREEAM certified buildings typically feature advanced technologies and systems that lower energy use, reduce waste, and minimize water consumption. Energy-efficient systems. BREEAM buildings often incorporate state-of-the-art heating, ventilation, and air conditioning, HVAC systems that are designed to use less energy while maintaining a comfortable indoor environment. Energy-efficient lighting systems, insulation, and window glazing all work together to minimize the building's energy consumption. Renewable energy. Many BREEAM certified buildings also integrate renewable energy sources, such as solar panels, wind turbines, or ground source heat pumps, which further reduce reliance on conventional energy and lower operational costs. Operational savings. The energy savings generated by these systems can result in significant reductions in utility bills. Over the life of the building, these savings can offset the initial costs of implementing energy-efficient technologies, offering a substantial return on investment, ROI. Resilience and adaptability. BREEAM also emphasizes resilience, ensuring that buildings are designed to withstand and adapt to the challenges posed by climate change. This includes considering factors such as extreme weather events, flooding, and rising temperatures. Climate change adaptation. BREEAM certified buildings are designed to be more resilient to the effects of climate change. This includes the use of sustainable materials, energy-efficient designs, and technologies that help manage water usage and reduce heat gain. Flood-resilient design. For projects located in flood-prone areas, BREEAM encourages flood-resistant design features such as raised foundations, flood barriers, and stormwater management systems. This ensures the building remains operational and safe even in the face of extreme weather events. Long-term durability. The use of high-quality, durable materials and systems ensures that BREEAM-certified buildings maintain their performance over time, requiring less frequent maintenance and repairs. This longevity contributes to the building's long-term sustainability and reduces the environmental impact associated with the construction and demolition of buildings. Health and well-being. Creating healthy environments. One of the standout features of BREEAM certification is its focus on enhancing the health and well-being of building occupants. With increasing awareness of the link between the built environment and human health, BREEAM integrates measures that promote occupant comfort, productivity, and overall quality of life. Indoor air quality, IAQ. BREEAM certified buildings prioritize indoor air quality, ensuring that the air within the building is free of pollutants and contaminants. Good IAQ is essential for the health of occupants, reducing the risk of respiratory problems, allergies, and other health issues. Ventilation and filtration. High-quality ventilation systems are a hallmark of BREEAM-certified buildings. These systems maintain a steady flow of fresh air while filtering out pollutants, dust, and allergens. The result is a more comfortable and healthier indoor environment for building occupants. Low VOC materials. BREEAM encourages the use of low volatile organic compound, VOC, paints, adhesives, and finishes, which contribute to improved indoor air quality. Low VOC materials help reduce the release of harmful chemicals into the air, creating a healthier living and working environment. B. Natural light and thermal comfort. Access to natural light and a comfortable indoor temperature are critical factors in creating a productive and enjoyable environment for building occupants. BREEAM places a strong emphasis on these elements, promoting designs that maximize daylight and thermal comfort. Daylighting. BREEAM-certified buildings are designed to optimize natural light, reducing the need for artificial lighting during the day. This not only lowers energy consumption, but also enhances occupant mood and productivity. Daylight also helps regulate circadian rhythms, improving sleep and overall health. Thermal comfort. Building occupants are more likely to thrive in environments where temperature and humidity levels are carefully controlled. BREEAM emphasizes thermal comfort by promoting energy-efficient heating and cooling systems and designing buildings with proper insulation and shading. C. Acoustic comfort. Acoustic comfort plays an important role in the occupant experience, particularly in commercial or office spaces. BREEAM-certified buildings integrate acoustic measures that reduce noise pollution and improve the overall acoustic environment. Sound insulation. To mitigate noise from both external and internal sources, BREEAM emphasizes the use of sound insulation materials and design features. This creates quieter indoor spaces, which is especially important in office environments where concentration and focus are key. Noise reduction systems. In addition to insulation, BREEAM-certified buildings may include noise-reducing systems such as sound-absorbing materials or strategically placed barriers to minimize unwanted noise. Productivity and occupant satisfaction. Research has shown that a building's environmental features directly influence occupant productivity, satisfaction, and overall well-being. BREEAM-certified buildings tend to offer healthier, more comfortable spaces that encourage higher levels of occupant satisfaction. A. Increased productivity. A growing body of evidence suggests that sustainable, healthy workspaces lead to greater productivity among employees. BREEAM's focus on natural light, thermal comfort, and IAQ can result in tangible benefits for businesses, such as reduced absenteeism, fewer sick days, and improved overall performance. Reduced sick building syndrome. By addressing issues such as poor air quality, inadequate lighting, and uncomfortable temperatures, BREEAM-certified buildings help reduce the symptoms of sick building syndrome, SBS, which can lead to headaches, fatigue, and respiratory issues among building occupants. Enhanced focus and engagement. The use of natural materials, good lighting, and quality air systems contribute to an environment that promotes concentration, engagement, and cognitive function, which in turn boosts productivity. B. Tenant and employee satisfaction. For commercial properties, BREEAM certification is a powerful tool for attracting high-quality tenants. Tenants are increasingly prioritizing buildings that support sustainability and offer a healthy, comfortable working environment. Employee retention. For businesses, BREEAM-certified buildings can improve employee retention rates. Employees are more likely to stay with an employer who provides a healthy, sustainable working environment. Furthermore, the reputation of working in a BREEAM-certified building can contribute to employee satisfaction and loyalty. Tenant demand and leasing premiums. Tenants are willing to pay a premium to occupy green, sustainable buildings. As a result, BREEAM certification can lead to higher rental income and a more attractive leasing proposition for landlords. Additionally, many tenants are now required to meet sustainability targets, making BREEAM certified buildings an attractive option. Social value and community impact. BREEAM certified buildings not only benefit their immediate occupants, but also contribute to broader social value and community impact. The environmental performance of a building can significantly affect the community in which it is located. Community engagement. BREEAM encourages developers to consider the wider impact of their buildings on the local community. This can involve integrating community spaces, creating public green areas, or supporting local initiatives. Public green spaces. Many BREEAM certified buildings feature green spaces, such as rooftop gardens or landscaped areas that are open to the public. These spaces enhance the quality of life for local residents and provide a place for recreation, social interaction, and relaxation. Local economy. BREEAM also supports the use of locally sourced materials and local labor during construction, which helps stimulate the local economy and reduce the carbon footprint associated with transporting materials. Conclusion: the holistic impact of BREEAM. The impact of BREEAM certification on building performance and occupant experience is profound and wide-ranging. From reduced energy costs and increased resilience to healthier, more productive environments for occupants, BREEAM certified buildings offer long-term value for developers, owners, tenants, and the environment. By focusing on sustainability, health, and comfort, BREEAM elevates the standard for what a building should offer, transforming the way we live and work in our built environment. As demand for green buildings continues to rise, BREEAM certification will remain a vital tool in ensuring that future buildings are designed for both environmental performance and occupant well-being. Part 7. BREEAM and the Future of Sustainable Architecture. Introduction: the evolving role of sustainability in architecture. Sustainability in architecture has become a critical aspect of modern design and construction. As the world faces growing environmental challenges, such as climate change, resource depletion, and urbanization, sustainable architecture has emerged as a solution to reduce the negative impacts of the built environment. Among the various green building certifications, BREEAM, Building Research Establishment Environmental Assessment Method, has proven to be one of the most influential and widely recognized systems for promoting sustainable building practices. This part explores the future of sustainable architecture and the role BREEAM will continue to play in shaping this future. We will examine the evolving trends in green building practices, the role of innovation in driving sustainability, and how BREEAM is adapting to meet these new challenges. The growing demand for sustainable buildings. The demand for sustainable buildings has surged in recent years, driven by several global factors, including stricter environmental regulations, rising energy costs, increased awareness of environmental issues, and a shift in public attitudes toward sustainability. Environmental concerns and climate change. As the urgency to combat climate change intensifies, buildings, which contribute a significant portion of global carbon emissions, are being scrutinized for their environmental impact. In response, many governments and organizations are introducing more stringent sustainability regulations and carbon reduction targets for the built environment. Global carbon reduction targets. Governments around the world have set ambitious targets to reduce carbon emissions, and buildings must play a pivotal role in achieving these goals. BREEAM's emphasis on energy efficiency, renewable energy use, and low-carbon materials directly contributes to meeting these global climate targets. Net-zero carbon buildings. The trend toward net-zero carbon buildings, those that produce as much energy as they consume over the course of a year, is becoming more prevalent. BREEAM is increasingly incorporating strategies to help buildings achieve net zero carbon emissions, pushing the industry toward even higher standards of sustainability. B. Regulatory pressures and standards. As the demand for greener buildings grows, governments are imposing stricter regulations to ensure that new buildings meet environmental standards. BREEAM is evolving to stay ahead of these changes and to ensure that buildings can meet these future regulatory requirements. The European Union and global standards. In Europe, the European Union's commitment to climate neutrality by 2050, combined with stricter Building Energy Performance Directive (EPBD) regulations, places additional pressure on buildings to adopt greener practices. BREEAM's focus on energy efficiency and sustainability makes it an essential tool in meeting these evolving regulatory requirements. The push for whole-life carbon accounting. There is an increasing focus on the entire life-cycle carbon footprint of buildings, from construction to operation and eventual demolition. BREEAM is adapting to include whole-life carbon assessments to ensure that sustainability is prioritized at every stage of the building's life cycle. Innovation in sustainable design and BREEAM's role. The future of sustainable architecture will be shaped by innovative technologies, design practices, and materials that aim to push the boundaries of what is possible in green building design. As new technologies emerge, BREEAM continues to incorporate these innovations into its standards, ensuring that the certification system remains relevant and forward-thinking. A. Smart buildings and digital technology. Smart building technologies that use sensors, data analytics, and automation to optimize energy use, enhance comfort, and reduce waste are at the forefront of sustainable building design. The integration of these technologies with BREEAM standards is expected to grow, as they offer significant opportunities to improve building performance. Building Management Systems (BMS). Advanced Building Management Systems (BMS) use real-time data to optimize heating, cooling, lighting, and other systems, reducing energy use and improving occupant comfort. BREEAM encourages the adoption of smart systems that increase operational efficiency and reduce environmental impact. Internet of Things (IoT). The Internet of Things (IoT) enables buildings to collect and analyze data on energy consumption, water use, indoor air quality, and other parameters. BREEAM is integrating these data-driven technologies into its assessments to help building owners and operators make informed decisions about sustainability. Energy storage and renewable integration. Innovations in energy storage, such as advanced battery systems, allow buildings to store excess renewable energy generated during the day for use at night. BREEAM certified buildings are increasingly incorporating these technologies to reduce reliance on grid energy and improve sustainability. B. Green building materials. The materials used in a building have a significant impact on its overall environmental footprint. Future BREEAM certifications will place a greater emphasis on the use of low-carbon, renewable, and recyclable materials that contribute to a building's sustainability profile. Low-carbon and recycled materials. BREEAM has been evolving to recognize the importance of low-carbon and recycled materials in building construction. As manufacturers continue to innovate, new materials will help reduce the carbon intensity of buildings, and BREEAM will continue to integrate these materials into its certification criteria. Biodegradable and regenerative materials. Future advancements in biodegradable and regenerative materials will allow buildings to have an even smaller environmental footprint. BREEAM is looking into incorporating criteria that will assess the sustainability of new materials, such as bio-based composites and regenerative building systems. C. Modular and prefabricated construction. The growing trend of modular and prefabricated construction offers the potential to reduce waste, energy use, and environmental impact during the building process. BREEAM is evolving to accommodate these innovations by providing clear guidelines on how modular and prefabricated buildings can meet sustainable standards. Waste reduction and efficiency. Modular construction allows for more efficient use of materials and a reduction in on-site waste. This approach is inherently more sustainable than traditional construction methods, and BREEAM is exploring how best to integrate these methods into its certification process. Faster construction and reduced impact. Prefabricated construction also leads to faster building times, which reduces the environmental disruption during construction. BREEAM assesses not only the final product, but also the process, ensuring that the method of construction itself is sustainable. BREEAM and the circular economy. The concept of the circular economy, where resources are reused, recycled, and kept in use for as long as possible, is gaining momentum in the construction industry. BREEAM is increasingly focusing on how buildings can contribute to a circular economy by designing for adaptability, reusability, and resource efficiency. Designing for disassembly and reuse. Buildings designed for disassembly can be easily taken apart at the end of their life, with materials and components reused in future projects. BREEAM is encouraging designers to incorporate strategies that make buildings easier to disassemble, thus extending the life of the materials and reducing waste. Material recovery. BREEAM includes credits for the reuse and recovery of materials, encouraging designs that minimize waste and maximize the reuse of building components. Adaptability. Buildings that can be easily adapted to changing uses or upgraded with new technologies contribute to a more sustainable future. BREEAM supports the design of flexible spaces that can be reconfigured without major demolition or renovation, further promoting a circular approach to building use. Resource efficiency and waste reduction. BREEAM is increasingly focused on reducing resource use during both construction and operation. This includes minimizing the waste generated during the building process and ensuring that the building systems, such as water and energy, are used as efficiently as possible. Sustainable construction practices. BREEAM encourages contractors to use low-impact construction techniques that minimize material waste, reduce transportation impacts, and conserve water. Water and energy efficiency. In line with circular economy principles, BREEAM certified buildings are expected to minimize water and energy use through efficient systems and technologies, reducing the need for external resources. BREEAM's role in achieving global sustainability goals. As sustainable architecture continues to evolve, BREEAM's role as a global leader in green building certification will be crucial in achieving the United Nations Sustainable Development Goals, SDGs. These goals, which include combating climate change, promoting sustainable industry and innovation, and ensuring sustainable cities and communities, align closely with BREEAM's principles. Contribution to 11 Sudanese pounds. Sustainable cities and communities. BREEAM is a key player in creating sustainable cities by promoting eco-friendly buildings that support healthy, resilient communities. 12 Sudanese pounds. Responsible consumption and production. By encouraging resource efficiency, waste reduction, and the use of sustainable materials, BREEAM is helping the built environment contribute to sustainable consumption and production practices. 13 Sudanese pounds. Climate action, with its focus on energy-efficient buildings, carbon reduction, and resilience to climate change, BREEAM is playing a significant role in mitigating climate change. Conclusion. BREEAM's role in shaping the future. As the demand for sustainable buildings continues to grow, BREEAM will remain a critical tool in driving the global shift toward a more sustainable built environment. By embracing new technologies, materials, and design practices, BREEAM is evolving to meet the challenges of tomorrow, while ensuring that buildings contribute to a healthier, more sustainable future. Through its innovative certification system, BREEAM is not just evaluating the environmental performance of buildings today, but is also helping to shape the sustainable architecture of tomorrow. By staying at the forefront of green building practices, BREEAM will continue to lead the way in creating high-performance, resilient, and sustainable buildings for a better world. Part 8. The Economic Benefits of BREEAM Certification. Introduction. The intersection of sustainability and profitability. While the environmental and social benefits of BREEAM, Building Research Establishment Environmental Assessment Method certification, are widely recognized, the economic advantages are equally compelling. In a world where sustainability and profitability are often seen as opposing forces, BREEAM demonstrates that it is possible to achieve both. From reduced operational costs to enhanced property value, BREEAM certified buildings provide a strong economic case for sustainability. This part explores the economic benefits of BREEAM certification, illustrating how it leads to financial savings, increased asset value, and improved business outcomes. Whether for developers, owners, or tenants, BREEAM offers numerous economic advantages that contribute to a building's long-term success. Reduced operational costs. One of the most immediate and tangible economic benefits of BREEAM certification is the reduction in operational costs. BREEAM's emphasis on energy efficiency, water conservation, and sustainable materials translates directly into lower utility bills and reduced maintenance costs. A. Energy and water efficiency. BREEAM certified buildings are designed to use energy and water more efficiently. By incorporating energy-efficient systems such as LED lighting, high-performance insulation, and renewable energy sources, these buildings consume less energy, which directly translates to lower utility costs. Energy savings. Energy-efficient buildings reduce their reliance on non-renewable energy sources, which results in significant savings over time. By reducing heating, cooling, and lighting costs, BREEAM certified buildings lower operational expenses for both owners and tenants. Water conservation. BREEAM encourages the use of low-flow fixtures, rainwater harvesting systems, and water-efficient landscaping, all of which reduce water consumption and lower water bills. B. Long-term maintenance savings. Buildings that are built to BREEAM standards often require less maintenance due to the use of durable materials and energy-efficient systems. As these buildings tend to perform more efficiently over time, the need for costly repairs and upgrades is minimized. Durable materials. BREEAM certified buildings often incorporate high-quality, sustainable materials that have a longer lifespan than traditional construction materials. This reduces the frequency of repairs and replacements, leading to savings in maintenance costs. Reduced wear and tear. Energy-efficient systems, such as advanced HVAC systems and high-performance windows, put less strain on the building, reducing wear and tear and extending the life of building components. Increased property value and marketability. BREEAM certification can significantly increase the marketability and value of a property. As the demand for sustainable buildings grows, BREEAM certified properties are viewed as more attractive to investors, tenants, and buyers who are looking for buildings that align with their sustainability goals. A. Premium rents and higher occupancy rates. BREEAM certified buildings often command higher rental rates compared to non-certified buildings due to their superior energy efficiency, health benefits, and overall performance. Tenants are increasingly prioritizing sustainability, and businesses that operate in green buildings can often justify paying a premium for these advantages. Attracting high-quality tenants. Many businesses, particularly those in sectors such as finance, technology, and education, are prioritizing sustainability in their office spaces. BREEAM certification helps property owners attract high-quality tenants who value eco-friendly and healthy working environments. Occupancy rates. Sustainable buildings often experience lower vacancy rates due to their appeal to a broad base of environmentally conscious tenants. The combination of energy efficiency, better indoor air quality, and comfortable working conditions contributes to higher tenant satisfaction and retention. B. Resale value and asset appreciation. BREEAM certification enhances a property's resale value by making it more attractive to potential buyers. As sustainability becomes an increasingly important factor in property investments, BREEAM certified buildings are expected to see long-term appreciation in value. Growing demand for green buildings. Investors are becoming more aware of the long-term benefits of owning sustainable buildings, including the potential for higher rent yields and lower operational costs. This increased demand for green properties can drive up property values, making BREEAM certified buildings a valuable asset. Future-proofing investments. Buildings that meet sustainability standards are better positioned for future regulations and climate-related challenges. As governments introduce stricter environmental laws and carbon reduction targets, BREEAM certified properties are more likely to meet these requirements without needing significant retrofits, which helps protect the investment's value. Access to incentives and financing. Governments, financial institutions, and insurance companies are increasingly offering incentives and favorable terms for buildings that meet sustainability criteria, including BREEAM certification. These financial benefits can help offset the initial costs of construction and increase the overall return on investment. A. Tax incentives and grants. In many regions, governments offer tax incentives, rebates, or grants for buildings that meet specific environmental standards. BREEAM certification can qualify building projects for these financial incentives, further enhancing the economic benefits of sustainable design. Green tax credits. Many countries provide tax credits for green building certifications. These tax breaks help reduce the overall cost of construction and can make BREEAM certified buildings more financially attractive to developers and property owners. Government grants. In some cases, government grants are available to support the development of energy-efficient and sustainable buildings. These grants help offset the initial costs of meeting BREEAM standards and encourage the adoption of sustainable building practices. B. Green financing and lower borrowing costs. Banks and financial institutions are increasingly offering green loans or sustainability-linked financing to developers and property owners who are pursuing green building certifications such as BREEAM. These financing options often come with lower interest rates and more favorable terms, making it easier for developers to secure funding for sustainable projects. Green bonds. BREEAM certified buildings may qualify for green bond financing, which allows developers to raise capital at lower rates due to the lower risk associated with sustainable investments. Green bonds are a popular way to fund sustainable development projects, and BREEAM certification can make these projects more appealing to investors. Insurance benefits. Insurers may offer lower premiums for BREEAM certified buildings due to their enhanced resilience to environmental risks, such as flooding, heat waves, and energy price fluctuations. This can result in significant cost savings over the life of the building. Improved corporate social responsibility, CSR, and branding. For businesses that occupy BREEAM certified buildings, the economic benefits extend beyond operational savings and increased employee satisfaction. BREEAM certification can enhance a company's reputation and align its operations with sustainability goals, contributing to stronger corporate social responsibility (CSR) performance. A. Brand differentiation. In a competitive marketplace, businesses are increasingly looking for ways to differentiate themselves. BREEAM certification offers a powerful marketing tool that highlights a company's commitment to sustainability, which can improve its brand image and appeal to customers who value environmental responsibility. Attracting eco-conscious consumers. As consumer preferences shift toward environmentally conscious products and services, businesses that operate in BREEAM certified buildings can demonstrate their commitment to sustainability. This can help attract eco-conscious customers, increase brand loyalty, and enhance customer satisfaction. Investor confidence. Investors are increasingly factoring sustainability into their investment decisions. By occupying or owning BREEAM certified properties, companies can attract impact investors who are looking for businesses that align with sustainable practices. This can lead to increased access to capital and more favorable investment terms. B. Employee engagement and retention. Companies that operate in sustainable buildings tend to experience higher levels of employee satisfaction, which contributes to better engagement and retention. Employees are increasingly prioritizing sustainability when choosing employers, and a BREEAM certified building can make a company more attractive to top talent. Workplace well-being. Sustainable buildings designed to promote health and well-being, such as better air quality, natural light, and thermal comfort, contribute to a more productive and engaged workforce. Employees who are satisfied with their work environment are less likely to leave, reducing turnover and recruitment costs. Talent attraction. Companies that are committed to sustainability can attract a workforce that values environmental responsibility. This is especially important in industries where talent is competitive, and attracting top-tier employees can provide a competitive edge. Long-term financial sustainability. The economic benefits of BREEAM certification extend beyond immediate cost savings and property value increases. By investing in sustainable design and construction practices, property owners, developers, and businesses contribute to long-term financial sustainability. A. Resilience to future environmental challenges. BREEAM certified buildings are designed to be more resilient to environmental risks, such as extreme weather events, resource shortages, and rising energy prices. This resilience ensures that BREEAM certified buildings will continue to perform well in the future, protecting their value and minimizing operational disruptions. B. Future-proofing against regulations. As governments introduce more stringent sustainability regulations, BREEAM certified buildings are well positioned to meet these requirements. By proactively addressing sustainability issues, such as energy efficiency, carbon emissions, and water use, BREEAM certified buildings can avoid costly retrofits and remain compliant with future regulations. Conclusion: the bottom line of BREEAM certification. BREEAM certification offers significant economic benefits, including reduced operational costs, increased property value, access to financing incentives, and improved corporate reputation. These advantages make BREEAM an attractive proposition for developers, property owners, and tenants looking to achieve both sustainability and profitability. As the demand for green buildings continues to grow, BREEAM certified buildings will remain a key asset in achieving long-term financial success while contributing to a more sustainable future. Part 9. BREEAM Implementation, Challenges and Best Practices. Introduction. Overcoming barriers to BREEAM certification. Implementing BREEAM, Building Research Establishment Environmental Assessment Method certification in a building project can offer numerous benefits, from enhanced sustainability to increased market value. However, the process of achieving BREEAM certification is not always straightforward. There are several challenges that developers, designers, and contractors must address in order to successfully navigate the certification process. This part explores some of the common challenges associated with BREEAM implementation, such as upfront costs, complexity, and the need for cross-disciplinary collaboration. It also offers best practices for overcoming these challenges and ensuring a smooth certification journey. Understanding the BREEAM process. Before delving into the challenges, it's important to understand the basic steps involved in obtaining BREEAM certification. BREEAM certification follows a well-defined process that typically includes the following stages. Pre-assessment. During the design phase, a pre-assessment is conducted to evaluate the building's potential for achieving BREEAM certification. This step helps identify key areas for improvement and ensures that the project is on track to meet the desired sustainability goals. Design stage assessment. This stage involves a detailed evaluation of the building's design, including its energy performance, water use, material selection, and overall environmental impact. The design team works to incorporate BREEAM's requirements into the building's design and construction plan. Construction stage assessment. During construction, the building's performance is monitored to ensure that it meets the sustainability criteria outlined in the BREEAM assessment. Regular site inspections and documentation help verify compliance. Post-construction and certification. Once the building is complete, a final assessment is conducted to determine whether it meets BREEAM's performance targets. If the building passes, it is awarded certification based on its overall environmental performance. While this process seems relatively straightforward, several challenges can arise at different stages of BREEAM implementation. Let's explore some of the key hurdles. Common challenges in BREEAM implementation. A. Upfront costs and budgeting. One of the most frequently cited challenges for developers and owners considering BREEAM certification is the upfront cost. While achieving BREEAM certification can lead to long-term savings, the additional design, consultancy, and assessment fees required to meet the certification standards can be a significant barrier, particularly for smaller projects or organizations with tight budgets. Consultant fees. Engaging a BREEAM assessor or consultant to guide the project through the certification process is a necessary expense. These professionals help with pre-assessments, design reviews, and compliance checks. However, their fees can add to the overall project cost. Material and systems costs. Some of the sustainable materials and systems required to meet BREEAM criteria, such as energy-efficient HVAC systems, green roofs, or renewable energy installations, can increase the initial construction budget. Best practice for overcoming cost challenges. Early planning and budget allocation. Integrating sustainability goals and BREEAM certification into the project's initial design phase can help developers identify potential cost savings early on. Allocating a portion of the budget for sustainable measures, such as energy-efficient systems, can reduce the risk of cost overruns later in the project. Long-term ROI considerations. Emphasize the long-term financial benefits of BREEAM certification, such as energy savings, lower maintenance costs, and higher resale value, to stakeholders and investors. By focusing on the long-term return on investment, ROI, the upfront costs can be justified. B. Complexity of meeting multiple criteria. BREEAM assesses a building's environmental performance across a wide range of criteria, including energy efficiency, water use, indoor air quality, materials, and waste management. Achieving high scores across all these categories can be complex, particularly for large projects with multiple stakeholders. Cross-disciplinary collaboration. The successful implementation of BREEAM often requires close collaboration among architects, engineers, contractors, and sustainability experts. Ensuring that all parties are aligned and working towards the same goals can be challenging, particularly in larger projects where communication breakdowns can occur. Integration of sustainable technologies. Incorporating cutting-edge technologies, such as advanced energy systems, green roofs, and water conservation systems, requires specialized knowledge and expertise. Managing these technologies effectively and ensuring their integration into the design can be complex. Best practice for overcoming complexity challenges. Early engagement of experts. Engaging a BREEAM assessor or sustainability consultant early in the project can help identify potential hurdles and opportunities for achieving high scores across multiple criteria. These experts can guide the team through the complexity of the certification process and help integrate sustainability goals into the building's design. Clear communication and project coordination. Ensuring effective communication among all stakeholders is essential. Regular meetings, project management software, and clearly defined roles and responsibilities can help streamline the process and ensure that all parties are working towards the same sustainability objectives. C. Data collection and documentation. One of the most time-consuming aspects of the BREEAM certification process is the need for extensive documentation and data collection. To demonstrate compliance with BREEAM criteria, developers must provide detailed records of the building's design, materials, systems, and performance. This documentation is essential for the certification process, but can be overwhelming for project teams. Tracking and verifying compliance. Collecting and verifying all the necessary documentation can be challenging, particularly when there are many moving parts in a construction project. Ensuring that all materials and systems meet BREEAM requirements requires meticulous record-keeping and timely reporting. Ongoing monitoring. For certain BREEAM credits, ongoing monitoring during construction and post-construction is required to ensure that the building meets sustainability goals. This can involve measuring energy consumption, indoor air quality, and other performance metrics, which can be a logistical challenge. Best practice for overcoming documentation challenges. Centralized documentation system. Implementing a centralized system for tracking compliance and collecting data can help streamline the documentation process. Digital tools, such as cloud-based project management platforms, can ensure that all relevant documents are accessible and organized, making it easier to provide the necessary evidence for BREEAM certification. Regular progress audits. Conducting regular audits during the construction phase can help ensure that sustainability measures are being implemented correctly and that all required data is being collected. Early identification of gaps in documentation can prevent delays in the certification process. D. Maintaining performance post-certification. Once a building is BREEAM certified, it is important to maintain its sustainability performance throughout its life cycle. Buildings that meet BREEAM standards at the time of certification may not automatically continue to meet those standards as they age or as new technologies emerge. Ongoing maintenance and upgrades. Regular maintenance is crucial to ensure that systems such as HVAC, lighting, and energy-efficient technologies continue to operate optimally. Additionally, building owners may need to implement upgrades to keep up with evolving sustainability standards or to address changes in regulations. Tenant engagement. Occupant behavior can significantly influence a building's sustainability performance. Ensuring that tenants understand and adhere to sustainability practices, such as energy conservation, waste management, and water usage, can be a challenge. Best practice for overcoming post-certification challenges. Sustainability monitoring and reporting. Ongoing monitoring of building performance after certification can help identify areas where improvements can be made. BREEAM offers tools for post-construction monitoring that allow building owners to track energy use, water consumption, and other performance metrics. Tenant education and engagement. Providing tenants with information and resources on how to use the building's sustainable features can help maintain BREEAM performance standards. Regular communication, training, and incentives for sustainable behaviors can keep occupants engaged and motivated to maintain the building's green credentials. Best practices for achieving successful BREEAM certification. In addition to addressing the challenges outlined above, developers and property owners can implement several best practices to ensure a smooth and successful BREEAM certification process. Set clear sustainability goals from the start. Establishing clear and measurable sustainability objectives at the outset of the project ensures that all stakeholders are aligned and working toward the same goals. Early integration of sustainability into the design process increases the likelihood of achieving high BREEAM scores. Engage a BREEAM expert early. Hiring a qualified BREEAM assessor early in the project can help guide the team through the certification process and identify potential obstacles in advance. An expert can provide valuable insights on how to maximize sustainability performance while minimizing costs. Ensure ongoing collaboration. Successful BREEAM certification requires input from various disciplines, including architects, engineers, contractors, and sustainability experts. Foster a culture of collaboration and open communication throughout the project to ensure everyone is on the same page. Track progress and document compliance. Regularly track the project's progress and document compliance with BREEAM requirements. Implementing a structured documentation and reporting system helps ensure that the necessary information is collected and submitted in a timely manner. Conclusion: navigating the challenges of BREEAM implementation. While the path to achieving BREEAM certification can be challenging, the rewards are well worth the effort. By addressing the challenges of cost, complexity, documentation, and post-certification performance, developers and property owners can successfully implement BREEAM and unlock the numerous environmental, economic, and social benefits of sustainability. With careful planning, expert guidance, and effective collaboration, BREEAM certification can be a powerful tool for creating buildings that are not only environmentally responsible, but also economically viable in the long term. Part 10. The Future of BREEAM, Trends and Innovations. Introduction: A Greener Tomorrow. As sustainability continues to dominate the global agenda, the role of BREEAM, Building Research Establishment Environmental Assessment Method, in shaping the built environment is becoming more critical. Since its inception in 1990, BREEAM has led the way in assessing and certifying the environmental performance of buildings. However, as environmental concerns grow and new technologies emerge, the future of BREEAM will evolve to address new challenges and opportunities. This part explores the future of BREEAM, including emerging trends in sustainable building design, innovative technologies, and evolving certification processes. It also looks at how BREEAM is responding to global challenges, such as climate change, resource scarcity, and urbanization, and how it is positioning itself as a leader in the next generation of green building standards. The growing demand for sustainability. Over the past few decades, sustainability has become a key focus for governments, businesses, and consumers alike. As climate change becomes an increasingly urgent issue, the demand for environmentally responsible buildings is expected to rise. BREEAM's role in addressing these concerns will only become more pronounced in the coming years. A. Global climate goals and green building standards. Countries around the world are setting ambitious targets to reduce carbon emissions and limit global warming. The Paris Agreement, for example, aims to limit global temperature rise to below 2 degrees Celsius above pre-industrial levels. To meet these targets, the built environment must undergo a profound transformation, with a focus on energy efficiency, renewable energy, and low-carbon technologies. Net zero buildings. The drive for net zero carbon buildings, structures that produce as much energy as they consume, has already begun, and this trend is expected to accelerate. BREEAM is adapting to this shift by incorporating more stringent energy performance standards and promoting the use of renewable energy sources, such as solar power and wind energy, in new building projects. Carbon footprint reduction. Future iterations of BREEAM will likely place an even greater emphasis on reducing the carbon footprint of buildings, not just in terms of energy use, but across their entire life cycle, from materials sourcing to construction and end-of-life disposal. B. Policy and regulation changes. As governments continue to introduce more stringent environmental regulations, the pressure on the building sector to comply with sustainable standards will intensify. For example, many countries are introducing laws that mandate energy efficiency standards or carbon reduction goals for new construction and renovations. Stricter regulations. BREEAM is likely to play an important role in helping developers comply with increasingly strict building codes. By providing a comprehensive framework for sustainable building design, BREEAM certification will help developers navigate new regulations and demonstrate compliance with emerging standards. Government incentives. Governments around the world are also offering financial incentives for green building certification. As public funding for sustainable projects increases, BREEAM certified buildings will be in high demand as they help property owners and developers qualify for tax credits, rebates, and other incentives. Integration of advanced technologies. Advances in technology are playing a key role in driving the evolution of BREEAM. As smart technologies, data analytics, and artificial intelligence (AI) continue to advance, they are reshaping the way buildings are designed, built, and operated. These innovations are transforming the concept of sustainability in the built environment, and BREEAM is evolving to incorporate these developments. A. Smart buildings and Internet of Things, IoT. Smart buildings, those equipped with IoT sensors and devices, are becoming more common, with systems that optimize energy use, monitor environmental conditions, and improve occupant comfort. These technologies not only enhance building performance, but also provide real-time data that can be used to improve sustainability outcomes. Energy management systems, EMS. Energy management systems that track and optimize energy consumption in real time are becoming standard in sustainable buildings. BREEAM is likely to incorporate these systems into future assessments, encouraging buildings to adopt technologies that improve energy efficiency. Real-time data analytics. As IoT devices generate vast amounts of data, real-time monitoring systems can provide insights into how buildings are performing and where improvements can be made. BREEAM will increasingly rely on this data to assess building performance and help developers make data-driven decisions that support sustainability. B. AI and machine learning. Artificial intelligence, AI, and machine learning are also becoming essential tools for improving building design and performance. AI can be used to analyze data, optimize building systems, and predict energy usage patterns. AI for predictive maintenance. AI can be used to predict when building systems are likely to fail or need maintenance. By using predictive analytics, building owners can proactively address maintenance needs before they become major issues, thus extending the life of the building and reducing operational costs. Optimized energy use. AI can help optimize energy use by adjusting lighting, heating, cooling, and other systems based on occupancy patterns. This reduces energy waste and improves overall building efficiency, an aspect that BREEAM will increasingly emphasize in future assessments. Focusing on human health and well-being. Sustainability is no longer just about reducing environmental impact. It is increasingly about improving the quality of life for building occupants. As research continues to highlight the importance of indoor air quality, lighting, and thermal comfort, the health and well-being of occupants are becoming central to green building standards. A. Biophilic design. Biophilic design, which incorporates natural elements into the built environment, has gained significant traction in recent years. Plants, natural materials, and daylighting are being integrated into buildings to create healthier, more inspiring work and living environments. Indoor air quality and ventilation. Future BREEAM assessments will likely place more emphasis on indoor air quality, ventilation, and the use of non-toxic materials to ensure that buildings promote the health of their occupants. Building materials and designs that reduce allergens, improve air circulation, and use natural lighting will become more common. Green spaces. Incorporating green spaces into urban environments is another trend that will shape the future of sustainable building design. Green roofs, vertical gardens, and outdoor spaces designed for relaxation and recreation will be key components of future BREEAM certified buildings, improving the physical and mental well-being of occupants. B. Mental health and productivity. As the link between workplace design and employee productivity becomes clearer, more businesses are seeking out office spaces that support mental health and well-being. Sustainable buildings that promote a positive indoor environment can enhance occupant satisfaction, reduce stress, and improve overall productivity. Lighting and acoustic comfort. BREEAM will continue to emphasize the importance of natural lighting and acoustics in building design. As more research is conducted on the effects of lighting and noise on productivity and mental health, BREEAM assessments may incorporate additional credits for optimizing these factors in workplace and residential buildings. Circular economy and resource efficiency. The concept of a circular economy, where materials are reused, recycled, and repurposed, is becoming an integral part of sustainable building design. BREEAM is already encouraging the use of sustainable materials, but in the future, it is expected that the certification will place even greater emphasis on resource efficiency and waste reduction. A. Sustainable materials and construction methods. Future BREEAM assessments will likely focus on the use of renewable, recycled, and low-carbon materials in building construction. Prefabrication and modular construction, which minimize waste and reduce construction time, will also play a significant role in sustainable building practices. Zero-waste buildings. Achieving zero waste in construction and operation is a key goal for future building projects. BREEAM will continue to promote practices that minimize waste and encourage the reuse of materials, ensuring that buildings have a minimal environmental impact throughout their life cycle. B. End-of-life considerations. As buildings age, their materials and components must be responsibly disposed of or reused. BREEAM is likely to continue its focus on promoting circular economy principles, including the consideration of end-of-life scenarios during the design phase. Deconstruction and material recovery. Future versions of BREEAM will encourage designs that make deconstruction easier and more efficient, ensuring that materials can be recovered and reused at the end of a building's life cycle. Global expansion and adaptation. As BREEAM's global presence grows, the certification system will need to adapt to the specific environmental, social, and economic contexts of different regions. This includes addressing the unique challenges faced by different climates, cultures, and economies. Regional adaptation. BREEAM is increasingly being adapted for use in different parts of the world, with region-specific criteria that account for local environmental conditions and regulatory frameworks. As climate change impacts regions differently, BREEAM will continue to evolve to meet these challenges and offer solutions that are relevant on a global scale. Conclusion: shaping the future of sustainable building. The future of BREEAM is bright, as it continues to evolve in response to emerging trends, technologies, and the growing demand for sustainable, healthy, and resilient buildings. As the building industry adapts to the challenges of climate change, resource scarcity, and urbanization, BREEAM will remain at the forefront of sustainable building certification, offering a comprehensive framework for creating buildings that are not only environmentally responsible, but also beneficial to the health and well-being of their occupants. Through innovation, collaboration, and a focus on the circular economy, BREEAM will play a critical role in shaping the built environment for generations to come. Part 11. Case Studies in BREEAM Certification. Introduction: Real-world applications of BREEAM. While the theoretical aspects of BREEAM are essential for understanding the system's framework and benefits, the true impact of BREEAM certification becomes evident when we look at real-world case studies. This part explores several notable buildings that have achieved BREEAM certification, showcasing the diverse range of projects, the challenges faced, and the results attained. Each case study highlights a different aspect of sustainability, from energy efficiency to occupant well-being, and offers insights into the practical application of BREEAM standards in varying environments and building types. By examining these examples, developers and stakeholders can gain valuable lessons that may help them in their own sustainability journey. The Edge Amsterdam, a global leader in sustainability. Building overview. The Edge in Amsterdam is a landmark office building known for its groundbreaking approach to sustainability and smart technology. Completed in 2015, it is considered one of the most sustainable office buildings in the world, achieving a BREEAM outstanding rating with an impressive score of 98.4%. Key features. Energy efficiency. The building incorporates a range of energy-efficient systems, including a highly advanced energy management system that uses data from over 28,000 sensors to optimize energy consumption. The building's energy needs are largely met by a combination of solar panels and geothermal energy. Smart building systems. The Edge is a true example of a smart building, with features like automated lighting, temperature control, and workspace personalization based on employee preferences. This contributes not only to sustainability, but also to occupant comfort and productivity. Sustainability innovations. The building's design emphasizes the use of recycled materials, water conservation systems, and a green roof to promote biodiversity. It also has a rainwater harvesting system that reduces the building's overall water consumption. Impact and results. The Edge has set a new standard for office buildings worldwide, demonstrating that it's possible to create a highly sustainable and energy-efficient workspace while also integrating cutting-edge technologies for improved performance. Its BREEAM outstanding rating reflects its leadership in sustainable architecture. Lessons learned. The integration of smart technologies and sustainable systems can significantly improve energy efficiency and reduce environmental impact. BREEAM's flexibility in evaluating both technical and operational aspects of buildings ensures that the certification process can accommodate the complexities of high-tech modern buildings. The Shard, London, a tower of sustainability. Building overview. The Shard, designed by architect Renzo Piano, is one of the most iconic skyscrapers in London. Completed in 2012, it stands at 310 meters tall and is the tallest building in the UK. Despite its massive scale, the Shard was awarded a BREEAM Excellent rating due to its commitment to sustainable design and operation. Key features. Energy efficiency and low carbon emissions. The building uses high-performance glass to reduce solar heat gain while maximizing natural daylight. It also has an energy-efficient HVAC system and efficient lighting, helping to minimize energy consumption across the entire building. Water management. The Shard incorporates rainwater harvesting systems that supply water to the building's cooling systems and landscape irrigation. It also uses water-saving fixtures to reduce overall water consumption. Sustainable materials. The construction of the Shard utilized sustainable materials such as recycled steel, and the building's design ensures that it can be easily deconstructed at the end of its life cycle, reducing waste. Impact and results. The Shard is a prime example of how high-rise buildings can achieve significant sustainability goals while being highly functional and aesthetically striking. It has become a model for tall buildings worldwide, demonstrating that large-scale projects can integrate BREEAM standards without compromising on performance or design. Lessons learned. Incorporating energy-efficient systems in large-scale buildings can lead to substantial reductions in carbon emissions and energy use. The importance of water management systems in urban buildings, especially in regions where water scarcity is a concern. The Crystal, London, a sustainability hub. Building overview. The Crystal, located in the Royal Victoria Docks in London, is a sustainability hub that serves as a conference center and an exhibition space for urban sustainability solutions. Opened in 2012, the Crystal achieved BREEAM Outstanding, making it one of the highest-rated sustainable buildings in the world at the time. Key features. Zero carbon and energy efficiency. The Crystal is a net-zero carbon building, meaning it produces as much energy as it consumes. The building utilizes renewable energy sources, including photovoltaic panels, to meet its energy demands. Building materials and waste reduction. The building's construction was designed with sustainability in mind, using low-impact, recycled, and renewable materials. Additionally, a zero-waste policy was implemented, ensuring that the construction process minimized environmental harm. Green roof and biodiversity. The building features a green roof that serves as both insulation and a habitat for local wildlife. This green space contributes to the overall sustainability of the building, helping mitigate the urban heat island effect and improve air quality. Impact and results. The Crystal is an exemplary case of how sustainability can be embedded in a building's design, not only to reduce environmental impact, but also to serve as a beacon for future development. Its BREEAM Outstanding rating reflects the building's dedication to sustainability and innovation. Lessons learned. Demonstrating leadership in sustainability can have a significant impact on public perception and influence future development trends. The importance of creating buildings that serve as educational resources, showcasing best practices in sustainability. 1 Angel Square, Manchester, a sustainable office building. Building overview. 1 Angel Square in Manchester is one of the largest BREEAM Outstanding rated office buildings in the UK. The building, completed in 2013, is the headquarters of the Cooperative Group and exemplifies the company's commitment to environmental sustainability. Key features. Energy and resource efficiency. 1 Angel Square uses a combination of passive design and active energy-saving technologies, including high-performance insulation and natural ventilation systems. The building also incorporates energy-efficient lighting and smart building management systems to optimize energy consumption. Renewable energy. The building has a substantial on-site renewable energy system, including solar panels and a biomass heating system, which contribute to the building's low carbon footprint. Sustainable materials and waste management. 1 Angel Square was constructed using a high percentage of recycled materials, and a robust waste management strategy was implemented to minimize waste sent to landfills during construction and operation. Impact and results. 1 Angel Square demonstrates that sustainable office buildings can offer not only environmental benefits, but also operational efficiency and employee satisfaction. The building's BREEAM Outstanding certification has helped raise the bar for sustainable office design in the UK. Lessons learned. The integration of renewable energy and energy-saving technologies is critical in achieving high BREEAM ratings, especially for large commercial buildings. Creating a building that fosters a positive working environment for employees can enhance both the environmental and social impact of the project. Bosco Verticale, Vertical Forest, Milan, a green icon. Building overview. The Bosco Verticale, or Vertical Forest, in Milan, Italy, is a pair of residential towers that are known for their innovative approach to incorporating nature into urban living. Completed in 2014, the towers are home to over 9,000 trees, 5,000 plants, and 11,000 shrubs, making it one of the most unique green building projects in the world. Key features. Biodiversity and green spaces. The most distinctive feature of Bosco Verticale is its extensive use of plants and trees, which are integrated into the building's facade. These plants help mitigate pollution, reduce energy consumption, and improve air quality, while also enhancing the aesthetic value of the building. Energy efficiency. The building's design emphasizes passive energy-saving measures, including shading and natural ventilation, which reduce the need for mechanical cooling and heating. It also incorporates energy-efficient lighting and smart building systems. Water management. The building uses an efficient irrigation system that recycles water for the plants and reduces overall water consumption. This system ensures that the building operates sustainably without putting excessive pressure on local water resources. Impact and results. Bosco Vertical has become a global symbol of sustainable urban living, demonstrating how innovative designs can integrate nature into dense urban environments. The building's environmental benefits extend beyond its own operation, serving as an inspiration for similar projects around the world. Lessons learned. Urban spaces can be reimagined with nature at the forefront, offering both environmental and social benefits. Sustainability and aesthetics can go hand in hand, providing valuable lessons for the future of urban architecture. Conclusion, insights, and future directions. These case studies illustrate the diverse ways in which BREEAM certification has been applied to buildings across different sectors, from high-rise office buildings to residential towers. Each project showcases how sustainability can be integrated into building design, construction, and operation, and the benefits that come from achieving BREEAM certification. Whether through energy efficiency, innovative technologies, or the use of renewable resources, these buildings demonstrate that sustainable architecture is not only possible but essential for the future. As BREEAM continues to evolve, these projects will serve as benchmarks for future developments, providing valuable insights and inspiration for the next generation of sustainable buildings.